Guys, welcome to the channel once again. So in the last video we had discussed about cost function of linear regression, which is given by summed over squared of errors, where error is given as y actual minus y predicted. This particular expression is also known as residual sum of squares. Residual sum of squares. So this error is nothing but also known as residual. That is why residual sum of squares. Okay, we had also discussed about why we minimize the vertical distance between the actual point and the regression line and not the perpendicular distance between the actual point and the regression line. Okay, we try to minimize vertical distance between actual point and the regression line. We had also discussed about why we not minimize the exact value of error. When we say exact value of error, that is y predicted, or sorry, y actual minus y predicted. Why we don't minimize this, we have already discussed about this. We also discussed why we don't minimize the absolute value of error, that is y actual minus y predicted. Absolute value means modulus of only the magnitude part. Why don't we minimize that? We have already discussed these 4 points in the last video. If you are watching this video for the first time, please visit my earlier video first, then you will be able to understand or go through this video properly. Okay, now coming to this the content of this particular video, we will continue with our cost function, which is given as the cost function, that is residual sum of squares, is ei square I equal to 1 to n, where ei is nothing but y actual minus y predicted. Okay, so we write it I equal to 1 to n. You have n observations, n is for n observations that you are given. Okay, y actual minus y predicted whole squares. Okay, this expression is also known as ordinary least squares function, or in short OLS function. Okay, now through this OLS function, or minimizing the error part, that is sum of squares of error, we try to estimate two parameters of linear regression. Okay, we try to minimize two parameters, that is beta naught and beta 1. So in simple linear regression, we have y equal to beta naught plus beta 1 x plus some error part. For a given x, in order to find the value of y, we need these value of these two parameters. Okay, now we'll see how we can derive the value of beta naught and beta 1 by solving this, or by minimizing this cost function. So how can we estimate beta 1 and beta naught? So beta naught and beta 1 can be estimated in a way, or are estimated, you can say are estimated instead of can be, are estimated in a way, we try to estimate in a way that the error is minimum, that is the residual sum of squares is minimum, ei square. Now we have simple linear regression as this, y equal to beta naught plus beta 1 x plus e. We can rewrite it as e equal to y minus beta naught plus beta 1 x. Okay, this is the error part we can write. So from here we can write RSS as I is equal to 1 to n y minus beta naught plus beta 1 x and whole square. Now we can minimize this cost function. So in order to minimize this cost function, we can take derivative of this cost function with respect to beta naught and beta 1. These are unknown. Okay, so del of RSS with respect to beta node, derivative of this cost function with respect to beta node, we can write it as, how we can write? We can write it as that is 2, okay, sigma, okay, y minus beta node plus beta 1 x, this, and this we can equate to 0 in order to minimize the value. Similarly, we can take derivative with respect to beta 1 and we can write it as 2 times summation, okay, summation, if we take derivative of this function with respect to beta 1, we'll get x into y minus beta node plus beta 1 x. This is what we will get, and when we equate this to 0, we can minimize the cost function with respect to beta 1. Okay, the estimator, that is beta node and beta 1, are solution of the two equation, that is equation number 1 is y minus beta node plus beta 1 x, and this is equal to 0, equation 1, and second equation is another, so this is x y minus beta node plus beta 1 x, okay, this equal to, this is your equation 2. So now from equation 1, what we can write? I is equal to 1 to n y minus beta node minus beta 1 x is equal to 0. From here we can write I is equal to 1 to n y minus, okay, this will be n times of beta node minus beta 1, and I is equal to 1 to n x, this is equal to 0. From here we can write n times of beta node is equal to y bar, that is mean of y values, minus beta 1 and mean of x values, where this y bar is given as that is mean of y is given as sigma of yi by n. Okay, so this value, and x bar is given as sigma of x I or sigma of x by n. Okay, okay. Okay, so here is one thing, one catch over here. So this will be when you write this mean, right, when you take mean of y bar, so this n value will go down, then only it will become y bar. So for simply, let me rewrite it once again. So if you have n over here, and this will not be this, actually it will come in the next line. So this will be sigma of y I equal to 1 to n minus beta 1 sigma of x I equal to 1 to n, and you will bring the n down, then we will get y bar minus sigma of y by n will be y bar, that is y mean, by minus beta 1 and x mean. Okay, this is how we get the value of beta node. Now coming to second equation, from equation 2, what we have sigma x y minus beta node minus beta 1 x is equal to 0. This is your equation 2. From here we already know that beta node is given as y bar minus beta 1 x bar. Okay, this we already know from here. Okay, so we can substitute the value of beta node. We will get sigma x y minus y bar, and when you minus minus it will be plus beta 1 x bar minus beta 1 hat x, sorry not hat, beta 1 x equal to 0. From here we can get, so from here we can get sum over, that is sum of y minus y bar plus, okay, plus this will be your or one second, okay, yeah, so this will be written as sum over, that is first we'll have beta 1 sum over x minus x bar into x, and this will be equal to 0. So we can write it as sum over x of y minus y bar plus, sorry not plus, let's take it to the other side, equal to, this will become beta 1 summed over x xi, not xi, sorry, this here I have done some mistake. So this will be your x bar minus x into x, okay. So if we take this to the right side, we will get x minus x mean into x. From here we can write beta 1 equal to summed over x y minus y bar divided by summed over x minus x bar into x, and from here we can write, so what we can write now, we will add a term over on the numerator. So from here let's write it down. From here we can write sigma y minus y bar into this x, and x will go, okay, into x minus x bar by summed over x minus x bar whole square. We have added this term in the numerator and 1 in the denominator, okay. So this is the final value of beta 1. So finally we have estimated the value of beta naught and beta 1. Beta naught is given by y bar, that is mean of y values, all the observations, given observations y, minus beta 1 into mean of all the x observations, and beta 1 can be written as summed over actual y minus mean of y into actual x minus mean of x values divided by summed over x minus mean of x whole square, okay. This way we can estimate the value of beta 1 and beta naught. Yeah, so that's it for this video guys. I know this video has been a little longer, as well as a little mathematical calculations involved here, but this is required. We need to understand how are the parameters in linear regression getting calculated in order to understand how linear regression exactly works, okay. So that's all for this video. If you like the video, please give a thumbs up. If you have any question, any doubt, please post it in the comment section. I will 100% try to reply to each one of you. All the best guys. Thank you. Also in the next lecture I will try to show you a Pythonic implementation using some artificially generated data or synthetic data. I will generate some synthetic data related to quarterly revenue of a company and its stock price, and I will show you how we can implement it in Python. uh, I will show you two different ways to implement in Python using Python library. That is, one is scikit-learn and the another is stats model. And I will also show you how you can implement it from scratch without using any library. Okay, the next video will be interesting. So please follow the channel or subscribe to be updated for the next videos. Okay, thank you, bye.